Okay, so this is Practical 1 Study Guide Review Part 2, and we're going to be covering the microscopes. So this is our study guide here you see on the screen. There are a couple of different types of microscopes. The first type microscope is called an optical. That means that the image is directly seen by your eyes and it's not processed by a computer. And there are two types of optical microscopes. The first one here, I'm going to circle in green and label number 1. That is a simple microscope. It's also a magnifying glass, but a magnifying glass is a simple microscope, and it's simple because it only has one lens. The second type of optical microscope, I'm going to label in number 2 here, is a compound microscope. And it's called compound because it has multiple lenses, 2 or more. So let me change colors here. Right here is one set of lenses, and then down here is another set of lenses. So you have 2 or more sets of lenses. Okay. So be able to label that both of these are optical microscopes. This one specifically up top is a simple microscope, and specifically the one at the bottom is a compound microscope. Going on to the next page, then we have non-optical microscopes, meaning that you're not directly seeing the image. A microscope is going to see the image, and then it's going to send that image to a computer, and that computer is going to process the image, and then you're going to look at the image through the computer, okay? So there's an indirect image there. So those are called non-optical microscopes. The first one is called a scanning electron microscope, and it's called scanning because it's only going to scan the surface features. And this right here, all these images are images from scanning electron microscopes. A bunch of these are pollens. So it's scanning the outside of these pollens, but you can't see any internal structures. So if I gave you a picture of anything looking like these and asked you to identify what type of microscope produced these images, you're going to tell me a scanning electron microscope. There's another kind of non-optical, remember up here, non-optical microscope, and it's called a transmission electron microscope. The transmission electron microscope will let you see internal features. So here you're seeing inside of a cell, and you're seeing the mitochondria here, the nucleus here, you're seeing the centrioles and other internal structures. So if I if I give you a picture like this on a quiz or on a practical, and I ask you to identify the type of microscope that produced this image, you're going to tell me the transmission electron microscope, because again, you can see the internal features. The compound microscope, remember this one down here at the bottom of the screen is a compound microscope. You have to know the parts of the compound microscope. And here on the left side, you see the parts, and on the right side, you're seeing the functions of each of those parts. So on the quiz and on the practical, you need to identify both the part and the function, okay? But again, pay special attention to the question. Some questions will say identify the part, and other questions will say identify the function. There is a video already created about the parts of the microscope and the function. So I'm not going to go into details with that here, but I will put that video into your Practical 1 module. Here are some more parts and functions of the compound microscope. And here is an image here where it's pointing to each of these parts. Again, that is in that video. Okay, care of the microscope. When you are moving the microscope, you always, always, always carry it with 2 hands. I'm going to go back up to this image. You're going to put one hand here on the arm, and you're going to put one hand right down here underneath the base, okay? So you're always going to carry the microscope with 2 hands. then you're always going to pull or unplug the microscope by the plug. Never yank it by the cord because the cord can separate from the plug. You're always going to put the stage all the way down. The mechanical stage should go in the middle, and the scope should be returned to the scanning objective, and you should wrap or fasten the cords. There should never be any hanging cords. So now what I'm going to do is I'm going to demonstrate. Let me make this bigger. Hang on just a sec. Come on. Okay, so I'm going to demonstrate the microscope now. Okay, let me rearrange my scope here on my camera. Okay, I'm just going to have to bring it down like this. Okay, so you're seeing a compound microscope right here. This is the arm, and this is the base. So you would put a hand on the base and a hand on the arm, and that's the way you would carry it. Okay, I'm going to increase this here so you can see it better. Forgive me, my camera is not, there we go, is not going straight at it. Okay, so when you're putting the microscope up, you need to, again, fasten the cord all the way around because you do not want to have any hanging cords. So if the cord is not fastened and it's hanging, it is not put up correctly. Still trying to get my camera. Okay. Okay, so this is our stage right here, and you want to lower this stage all the way down. So you're going to lower this stage all the way down. You can, I don't know if you can see it moving, but it's going down. So when you put it up, you want to make sure this stage is all the way down. You also want to make sure that this smallest objective, called the scanning objective, it has a red print right here. That scanning objective goes down. Okay, so scanning objective down, stage all the way down, and cord all the way wrapped. Then you also want to center this stage. So let me get it right here. I'm trying to get the best angle for you. Okay. Okay, so you see right here, this stick sticking out, that means that the stage is not centered. So you want to take these two little dials here, and you're going to move it until that little arm right there gets centered in the very middle of the microscope, so that when you're putting it up, that arm does not catch and break off. Okay. So again, let's go back over the steps of how to put up a microscope. You're going to be carrying it with two hands, this hand on the arm, this hand on the base. You're going to make sure that the cord right here is fully wrapped. You're going to pull not by the cord, but by the plug when you're unplugging it. You're going to lower the stage, put the smallest objective, which is the scanning objective, down, and you're going to use these knobs to center the stage. Okay, so again, this arm is not sticking out. So those are all the processes involved in putting up a microscope correctly. Okay, now I'm going to go back to the shared screen here. Well, I'm trying to share it. There we go. Okay. So now we're going to go to the definitions involved with a microscope. You have a few definitions. You need to memorize these for both your quiz and your practical. The first definition is parfocal. That means as you change the objective, so as you move from one objective to another, the image will remain in relatively good focus. Then par-center, as you change the objectives or as you move from one objective to another, the image will remain pretty much in the center of the field. Then field is the area that is visible through the microscope. Depth of field means the depth or the thickness of the specimen that is simultaneously in focus. So again, make sure you memorize these definitions for both the quiz and the practical. Okay, you need to be able to calculate the total magnification. So total magnification is the eyepiece magnification times the objective. So here are the objectives. Right here, there's the name of the objective. So you have the scanning objective, and it's going to have red printing on it, and it has a magnification of 4 times. Then your low objective has yellow print. So right here, down here, you can see this is yellow right down here. No, here's yellow, sorry about that. And it's going to have a 10 magnification. Then your high objective is in blue. So this one, you can see that blue ring right there. That is going to be our high objective, and it has a total magnification, or sorry, a magnification of 40. Then our oil is going to be in white. So this one down here is our oil. It's the longest objective, and it has a magnification of 100 times. And you have to be able to identify, or sorry, to multiply out or calculate out the total magnification. So again, we are going to share a different screen here. Okay, so on this screen, we're going to calculate total magnification. Okay, so again, total magnification is calculated by multiplying the ocular or the eyepiece by the objective. So in this one, if I told you that the ocular has a magnification of 5 and you're using the scanning objective, what would be your total magnification? So again, 5. Well, hang on just a sec, I gotta grab my pen. Okay, ocular of 5 times my scanning objective, and remember my scanning objective from the screen above is going to be 4 times. So 5 times 4 is going to be a total magnification of 20. Number 2, if my ocular is 5, so my first number I'm going to multiply is 5, and I'm going to multiply it by my low power. My low power is a magnification of 10. 5 times 10 would be 50. So my total magnification here would be 50. Okay, let me erase these and we will go on to our next ones. Okay, number 3. Here, number 3 says I have an ocular of 5, and I'm going to multiply that by my high power objective. My high power objective is 40. 5 times 40 would give me 200. Number 4, I have an ocular with a magnification of 5, and I'm using the oil objective. The oil objective gives me a magnification, of 100. So 5 times 100 is 500 total magnification. I'm going to erase these and we're going to go on. So again, we're going to do the total magnification. So our ocular here is 10. So now we've changed the magnification of our ocular. So we're going to multiply 10 times our scanning. Remember, your scanning objective has a magnification of 4. So 10 times 4 means our total magnification is 40. The next one, our ocular is 10. So we're going to multiply 10 times our low power objective. Remember, the low power objective has a magnification of 10. So 10 times 10 means our total magnification, whoop, that's kind of sloppy, is 100. Number 7, our ocular again is 10. So we're going to multiply 10 times our magnification from our high power objective. Our high power objective has a magnification of 40. So 10 times 40 means we have a total magnification of 400. Okay, now we're going to erase these and we're going to do just a few more. Let's do number 8 right here. Number 8 says we have an ocular of 10 and we're going to use our OL objective. Remember, our OL objective has a magnification of 100. So 10 times 100, whoops, gives me 1,000. 10 times 100 equals 1,000. And our last two down here, we've changed the ocular again, and this time our ocular is going to give us a magnification of 25. So our ocular is 25, and in the number 9, we're multiplying that by our high power objective. Our high power objective gives us a magnification of 40. So 25 times 40 is 1,000. Number 10, we're using an ocular of 25 magnification again. So 25 times, this time we're using our scanning objective. So we're going to do 25 times 4 because our scanning has a magnification of 4. And this is going to give us 100. Okay. So again, make sure you can do these calculations for both the quiz and for your practical number 1. So for quiz 1 and practical 1. Okay, let me go back to our other sharing, our other document. So again, on this document right here, or on this page right here, make sure you have memorized the magnifications of each one of these objectives, and make sure you can identify each of these objectives on a microscope. So if I had a picture that looked like this right here, and I said identify number 2, number 2 has a yellow ring, so number 2 is going to be our low power objective, because you can see right here the print color on it is yellow. So number 2 is going to be our low power objective, and it has a magnification of 10 times. Number 1 has a red ring right here, so number 1, red ring, is going to be our scanning objective, and it has a magnification of 4. Okay, so make sure you have memorized this little page right here, and you can calculate the total magnification. Okay, that is going to be the end of our Practical 1 Study Guide Part 2.